short video to show you how to work some average atomic mass problems. In order to find average atomic mass, you're going to need to know two things. You're going to need to know the percentage of each isotope, and you're going to need to know how much that isotope weighs. There's one isotope, and there's the other. So how does the math work? It's the percent after you've moved the decimal place over times the mass plus the next percentage times the next mass. If you multiply the percentages, the green one ends up being 43.55 and the blue one ends up being 20.00. You add those two together and you get a final of 63.55 AMUs. We know that the percentage times the mass plus the next percentage times the next mass plus the next percentage times the next mass, and if we had three more isotopes, we'd keep on doing the same thing. This gives us a grand total of, after you do all the math, the blue gives us 30.37 AMUs, the green gives us 0.2506 AMUs, and the purple gives us 1.433 AMUs. When you add them all together, you get 32.05 AMUs. This one is slightly different. You have four isotopes for lead. It doesn't give you a number of AMUs. You have to calculate the AMUs. So here is the math that you would do for this isotope, 82 plus 126. Here's the math you do for that isotope, for this isotope, and this isotope. So the first isotope is 204 AMUs times the 1.37%. The second isotope is 206 AMUs times the 26.26%. The third isotope is 207 AMUs times the 20.82%. And the fourth isotope is 208 AMUs times 0.5155. When you do the math for each one and add them all together, you get 207.2 AMUs. The last problem is a little bit different. It doesn't give you the percent abundance of each isotope and ask you to find the average atomic mass. This one reverses the situation. It's giving you the average atomic mass. It wants you to find the percentage of each one. To solve this, we're going to let X equals the percent, that is the 78.92 AMUs. And we'll let Y represent the percentage of the other isotope, 80.92 AMUs. We also know that the percentage that is X plus the percentage that is Y is going to add up to be 1. Not 100%, it's going to add up to equal 1. So if X is 20%, we'd call that 0.20. Then Y has to be 0.80 or 80%. So we're going to let X plus Y equals 1 be one equation, and we're going to let 78.92X plus 80.92Y equal the average atomic mass given to you in the problem. Now that you have these two equations, you can either use a system of equations that you may have learned in math class to solve this, or you can do it the old school way. The old school way is to solve for Y and then substitute 1 minus X for Y in the equation below. Once I've got it substituted, it's just down to actually doing the math and solving for an answer. I've got a positive value for X in red, a negative value for X in purple. I've got a 80.92 in green on the left-hand side and a 79.90 on the right-hand side. If I simplify the whole equation, I get 1.02 is equal to 2x. Therefore, x is equal to 0.501, or 50.1%. Now we know that x is equal to 50.1%. Let's scroll back up and see what this means. X was 50.1%, which means y has to be the other part, 49.9%.